My name is Prashant Desai. I lead product management at NetApp for Azure NetApp Files. Uh, I've also been in my time at NetApp responsible for bringing to market a number of other cloud offerings, namely Cloud Volume Service, Cloud Volumes ONTAP, and various software-defined ONTAP offerings. I have around 10, 12 minutes of budget with me, and what I plan to cover is a quick overview of Azure NetApp Files and the solution we have with JetStream for AVSDR. Again, at a high level, the partnership with NetApp and Microsoft, it started out with the intent and the vision to enable enterprise customers to land their most stringent business critical workloads in Azure, to enable customers to get the same performance, the same data management they get in their data centers on-prem. How could we deliver it in Azure while giving customers the same experience, the cloud flexibility, the agility that they get in Azure? And with that mission statement, we ended up building a platform from the scratch, which has really three components. At the bottom of the stack is really think of it as industry leading all flash ONTAP arrays that are sitting in Azure data center. The second component, think of it as new IP that the two companies co-develop, which integrates the filers into Azure Data Center, into Azure's SDN, so that volumes created on ONTAP show up as local VNet entities. And third layer is the distributed control plane. Again, that is the new IP that we developed together, which manages these fleets of clusters, ONTAP clusters that are sitting in Azure Data Center, uh, delivering capabilities that are required for a multi-tenant service, such as volume placement, rebalancing, telemetry, connecting with Azure Support Center, security, and then, of course, plugging into the Azure ARM architecture. The service was built and is operated just like any other Azure service. And again, with the intent is to enable customers to do all the things they do in on-prem with the benefit of Azure. Today, this service is operational, available in 44 data centers globally. Thousands of enterprise customers are using it. Uh, High performance file protocols, the entire set, including newer protocols, easy options for customers to right size the performance for the workload they need. It's available in three simple performance tiers, which customers can create volumes in a specific performance tier and instantaneously, programmatically, either through Azure Portal API or CLI, they can move their volumes from standard, premium, or to ultra tier. This is all programmatically, instantaneously done. Volume sizes could be as small as 100 GB, can grow to hundreds of terabyte, and the aggregate footprint. We have customers who start as small as couple of terabytes, and within months, within days, have grown to multiple petabyte. Uh, Another uh, tenant of Azure NetApp Files, as we defined, was to bring to customers a workload experience. ANF, we believe, is not kind of a buffet of features, but it's a curated experience focused on the workloads we collectively want to go after. And ANF has now become a preferred platform for SAP running SAP in Azure, be it scale up HANA, scale out HANA, or SAP on any database. VMware with ONTAP on-prem being the preferred external storage for data stores. VMware is supported on ANF both through two options, mounting data stores for AVS or guest OS mounts, and then HPCDA workloads. Uh, some of the things I wanted to kind of quickly highlight are the team has spent a lot of time imagining, reimagining what it means to build a workload-based experience. For example, SAP HANA, we develop along with our Azure compute teams concepts such as application volume groups, which ensure that ANF high performance storage and the high-end compute that are needed for SAP can be co-located programmatically through proximity placement groups and through concepts like application volume groups. Customers can deploy hundreds of landscapes in a matter of minutes, fully automated, and we ensure that the network layout, the layout of the volumes on the clusters is optimal. The same concept kind of shows up in VMware, where through concepts like zone-aware volumes, customers can ensure that the AVS private cloud and ANF data store, they're all co-located in the same availability zone. And again, I think that's always an endeavor for this team is to make sure we deliver an experience that completes customers' jobs to be done and workloads to be deployed. On the AVS side, building upon what Justin has said, one of the key value props of the solution we have, the ANF solution can be used to uh, serve as guest OS. You can mount NFS volumes, or it can also be used uh, to back data stores. And the scenario where we see customers gravitating to an ANF like external storage is where workloads are storage heavy, where they need to scale storage independently of compute. This could be for production workloads or for DR. That is where ANF can give a far superior TCO. I have a link to the TCO calculator here, and we found that customers can get as much as 10 to 30% saving TCO, especially if their application is storage heavy, or it's something like DR where they really want to minimize the amount of compute they want to stand up. And then on top of it, you add the benefits that ANF and ONTAP bring to the table, such as snapshots, cloning, incremental snap mirrors. It frees up a lot of resources on the compute time and also enables customers to do the same workflows they are used to and familiar with on-prem. They can do it with AVS and in Azure. Moving on, the JetStream and the ANF partnership I'll start with is anchored in the common focus, our customer focus, where ANF is used for large enterprise customers, prefer ANF for business critical workload. That married very well with the unique technology JetStream has with continuous data protection, uh, near zero RPO, RTO. That really, really marries very well with what ANF customers want and where the product is used for. So we started interacting and engaging with JetStream CTO Sergey and his team, and it was a very quick and easy decision for us to come together to integrate a solution, test, qualify, and make it available for our customers. A solution can be used in two scenarios. It could be used for disaster recovery from on-prem to AVS for workloads that require near zero RTO. It really shines really well there. It can also be used in the standard model that Dennis talked about for workloads that do not have such a stringent RTO. And what helps in here is ENF has three performance levels to pick from at three different price points, and customers can, even for the continuous rehydration, they can minimize their cost by rehydrating to ANF standard performance tier. And when the DR event happens, they can up level the performance to premium or ultra based on their actual workload need. That really enables customers to minimize their cost on infrastructure. The same configuration or architecture can also be used for customers who've chosen to go production in AVS with ANF. They're running certain workloads production in Azure on ANF. They can use the JetStream solution for disaster recovery solution within Azure, between two AVS private clouds. And again, there is a link to detailed description and architecture on azure.com. Next slide just gives a quick overview of the architecture. The architecture is very, very similar to what Dennis covered. The protected side architecture is exactly similar. The one on the recovery side is also similar. What you see here is ANF becomes the layer which is serving the data store, and there is continuous rehydration configured. And as I mentioned, this ANF volumes which are serving the data store can be configured to land in the lowest performance, cheapest ANF tier, which is standard tier. And when a disaster recovery event happens, instantaneously, customers can choose to move some of the data stores to premium tier. They can move certain data stores to ultra tier, and they can keep the remaining in standard tier. So there is this flexibility available for customers to right size to meet their application needs as and when the DR happens.
One question that when you brought up before about some of the unique workloads, you talked about HPC, VDI, which obviously have very unique, like high reads, high throughput, really odd patterns. How does ANF handle giving what's needed to those ones? Is that sort of the tiering per volume that you just talked about?
Yeah. So I think it's a good question. ENF does really well in workloads one like SAP HANA, where sub-millisecond latency is critical. ANF is built and engineered to deliver those kind of latency. Also does exceedingly well for random reads and random writes for metadata heavy operations. And I think that is a section of HPC where we do really well, where there are millions of files and metadata heavy operation, oil and gas seismic analysis, chip design, EDA. For VDI, user profiles, where customers have very large VDI deployments and they need very high performance for user profiles. And the same benefits then come into the VMware side, where we see ourselves interacting with infrastructure architects and admins who are standing up VMware infrastructure to support a variety of workloads. In many cases, these architects don't even know what application or workload is going to run when they stand up a VM and they hand it over. So the ability to right size and change the performance tiers dynamically as and when needed, I think it becomes super valuable, especially in a VMware environment.